So now I'm going to begin writing some of the code we just read about in the book. Here I have the PEP8 program open, and on the top left where it says source code, I'm going to put some instructions in the assembly language. The first thing that we're going to do is we're going to code up this Hello World program that was in your book and in your slides. We're going to do it in assembly, and we're going to see that it produces the same machine code as before. So I type in the word Caro, and I want you to notice, if you look very closely, as I spell the word right, the color changes. When you guys are typing up code, in the beginning students always try to use regular Notepad, or even Microsoft WordPad it doesn't actually produce text documents, and then they can't figure out why it won't work. Or they'll use Notepad to type these things out, and they misspell everything. They put a 0 instead of an O. So the color coding is a tool that modern text editors have to let you know that you are writing code in the right language. So Caro to output a character, and I want to output the H for hello. So I'll type it in here, and I see that that is hex 48. To type it out, I do the 0x. Remember, there's 2 bytes per assembly language instruction, so I need that first byte to be all zeros, and the second byte can be the 48. In an assembly language program, I can do a semicolon, and then afterward, this is ignored. So this is for you, for the next guy. And believe it or not, this is probably the most important thing about programming, is always have the mentality that when you're writing a piece of code that you are not going to remember what you were thinking when you wrote it. I don't even remember what I meant to do in a piece of code 2 or 3 days later, because even though this is better than machine code, it's still really hard to understand. Just a simple comment like this is supposed to output an H is immensely helpful. People have died because somebody would say a comment that was not accurate. And then people think the software does something it doesn't do. So you do need to make sure that your comments match your code, and you should check that they're correct. But being able to make sense of what you wrote is incredibly important. So I'm going to do hello world. I output an uppercase H. The next thing I want to output is a lowercase e, which is 65. So 0x65. And another thing is people pretty quickly, if they are writing machine code, would memorize the ASCII character sets. We are not going to get there. There's no need for it for us. We are using assembly really just as a way to say, hey, next time I show you something, you'll appreciate how nice you've got it. An L in ASCII, a lowercase l is 6c. Just a little aside, programmers hate a lowercase l because you can't tell the difference between a 1 and an L. They look so similar, and in some fonts they look exactly the same. This, by the way, is an L. So continuing on, we need to output that line twice. The most common source of error is what I just did. When you copy something and you paste it and you accidentally copied the wrong thing. We call those copy-paste errors. They can really kill you. The last thing that we need to output is the O at the end of the word hello, and that is 6F. So again, 2 bytes of nothing followed by a 6F, and a note to myself, this is outputting the O in hello. You always in machine code had an instruction to tell the CPU to stop so that it didn't continue to try and execute random memory. Lucky for us, the stop instruction is what this memory is filled with, but if you had already loaded something previously before you loaded this, it could be random. And then this is not going to be translated. This is just a note to the assembler that the file is over. We're finishing the file. So I could save it, but I can also build it. So the assemble button, here we've got this, we didn't use it before, but we have this toolbar button that will, if I did things correctly, translate the input into object code. This is, I'm probably going to leave this in the video. I've been making a mistake with every single instruction, a syntax error. A syntax error is something that prevents the assembler from even being able to read what you wrote. Another type of error is if I tell it the wrong thing. That's a semantic error. It did what I said, but I didn't say what I meant. Here, I just told it gibberish. My grammar was bad because every single instruction has to have an addressing mode. It needs to know how to interpret this operand. So these all need to be output for immediate mode. And now I will try to build the program. So an important thing about writing code is we always prefer to find out about errors as soon as possible. So I found out errors quickly if I misspell the word because of the syntax highlighting. I find out about errors during the assembly process if I hit that button and that little red dialog comes up. But semantic errors I generally don't find out until I run the program, which is why we try to come up and test every possible scenario of how we might run a program. We can't do every one, but many of them before we send it out. Now, what happened after I assembled it is we can see here that it generated some machine code. And if you recall, this is the same exact machine code we had last time. It's wrapping around. 500048 to output character 48 in immediate mode. So 50, 65, and 50. So instead of having to write char O, we could have written 50, or instead of writing 50, we were able to write char O. Another thing is it's giving us this this listing. So it is, for us, it's something we can go back and check. We can see that in memory address 0, it's going to load these 3 bytes of data. At memory address 3, it's going to load these 3 bytes of data when we go and load the program. It's possible, we'll see what symbol means in a little bit, but the mnemonic here is what this instruction corresponds to, and here we kind of see the assembly. So we get both our assembly code and the translation that it came up with. If I load this, here it's in memory, and I should be able to run it, and when I run it, it prints out the word hello. I'm sorry, I just scrolled this out. It prints out the word hello in the bottom. That wraps this up. I will record another video solving the problem of how to add 3 numbers together.